start recording. There we are. Excellent. So we are going to have a little introduction here to limiting and excess reactants. Last day, when we looked at titrations, we looked at a situation where we had an acid and we added exactly the right amount of base to it so that it was perfectly reacted. Yes? However, in this case, what's going to happen is we're going to put two reactants together and you're going to have like too much of one of them. It's not all going to be able to react. And that's what we call the excess reactant. And the one that we run out of is called the limiting reactant. The limiting reactant gets all used up. Page 50. And the excess reactant will have some left over at the end. Hi. We also infused it. Wow. Hi. Can I get it? Yes.
Let's grab that for you. Where have I got it? Oh, yeah. Come on now.
There we are. Okay. Pardon me? We have our stoichiometry test, which covers most of the units in the one, because this unit covers moles, it covers reactions, formulas, sig figs, unit conversions. Abbas, and you also need to write this, right? Okay, let's get you guys ready with that. We need one of these for each of you. And we need one of these for each of you. Okay, so sorry, the limiting reactant is the reactant that gets all used up, and the excess reactant there will be some left over. Okay, because we didn't pick the perfect quantities to react with one another. So consider the following balanced reaction. This is the simplest sandwich you could ever have. There are 2 slices of bread and 1 slice of cheese makes 1 sandwich. Okay, and I made the sandwich with I didn't put the other piece of bread on top because otherwise you could not see the cheese, and I wanted you to be able to see the cheese. All right, so let's imagine if you are given 3 pieces of cheese and unlimited bread, how many sandwiches could you make? 3 sandwiches. If you were given 4 pieces of bread and unlimited cheese, how many sandwiches could you make? 2. So if I were then to give you exactly 3 pieces of cheese and 4 pieces of bread, how many sandwiches could you make? You could make only 2, right? So what you're going to be doing in these problems is you're going to be finding out how much product can you make from reactant A, how much product can you make from reactant B, So how much product from reactant A? How much product from reactant B? So you're basically going to be doing stoichiometry twice. You're going to be taking reactant A, finding the moles of A, and then finding the moles of product. You're going to be taking reactant B, finding the moles of B, and then finding the moles of product. Once you've got that, you can only make the smaller number of product. Okay? The smaller number of product is how much can actually be made. Because I can give you 3 slices of cheese all you want, and you cannot make 3 sandwiches if you've only got 4 slices of bread. Yes?
So in this scenario, the bread limits the amount of product.
Yes.
So say I have 5 slices of bread.
Yes. Well, we're not going to do that because we are dealing in atoms and molecules. So we are able to, we're dealing in very large numbers. So it's not like we're going to have a half of a something.
Right.
Yeah? Okay. Yeah. So there we go. The bread then limits the amount of product, and so it is called the limiting reactant. And just so you know, the limiting reactant can also be called the limiting reagent. A reagent is just something that reacts. So it is a reactant, but you should be familiar with that term so that if you see it, you don't get freaked out by it. Okay, so a reagent is just a reactant. And we are going to refer to this so often that I'm going to start abbreviating it LR. Okay? So our limiting reactant is abbreviated LR. And then when you have an excess of something, that means you have too much of it and you'll have some left over. The excess is always going to have some amount left over. And in this case, our excess reactant is we have excess cheese. And so that is our excess reactant. And for this one, because excess sounds like XS, excess, right? Excess, they sound alike. So that's going to be how we represent our excess reactant, is the X and the S. So we have our limiting reactant and we have our excess reactant. So one of the things you're going to have to do is find the amount of product that you can make, which is the smaller amount. The other thing you might have to do is you might have to figure out which is the limiting reactant, identify the limiting reactant. All right, so I'm not really sure that we need this next example, and it's really simple, so maybe I need to get rid of it, but let's just assume that we have this little reaction here. Here is a following balanced reaction. We have one little, square thing with a triangle cut out hole in it. We have a triangle, and our product is like that. Could you please draw what will be present after the reaction takes place? So who is your limiting reactant? The little pair of pants things or whatever it is, the little square thing. Okay, so this one here is our limiting reactant, whereas the triangles are the excess reactant. So you could identify who is the limiting reactant, who is the excess reactant, how much product can we make? We can only make one because we only have one of our limiting reactant. Okie dokie. So the limiting reactant is this thing. The excess reactant is our triangle. So when we're figuring out how much product will be produced, find the amount of product that can be produced by each reactant, and whichever is the smaller amount is how much will be produced. So for any of these questions, you will be doing 2 calculations, okay? Okay, you're gonna go reactant A to product, and you're gonna go from reactant B to product. And when I say product, I'm talking moles, okay? Now, this amount that you produce from the limiting reactant, the smaller amount comes from the limiting reactant. That smaller amount, we actually call it the theoretical yield. In theory, if you were to do this experiment and use these chemicals in those amounts, that's how much in theory you should get. Okay? It's called the theoretical yield. This is how much you should get if conditions are ideal. So the theoretical yield is how much you should get if the reaction is perfect.
Okay, so the amount of product that could be produced by the reactant is, so that's just 2 calculations.
That's our 2 calculations. Yeah, that's the triangle on the pants, yeah.
And the smaller amount, how it comes from the limiting reactant.
Yes. Yes.
That amount, the smaller amount is called theoretical yield.
Yeah, the theoretical yield is how much product you should get if the reaction is perfect. That is the amount of product from the limiting reactant. Now, the reason we have a theoretical yield is later on we're going to be like, oh, and then somebody actually did the experiment in real life, and instead of getting the theoretical 10 grams, they only got 8 grams because, you know, real life isn't perfect. And if you get only 8 grams when you should have gotten 10 grams, you have an 80% yield. Okay, but we're not there yet, but I'm just telling you why we have a theoretical yield. All right. Next. Let's do it with some actual chemicals here. Consider the following reaction. When 6 moles of H2 react completely, okay, how many moles of H2O can be formed? So how many moles of H2O can we get from, because this is our product, yes, product, when we react 6 moles of H2. Could you guys finish that calculation for me, please? And then if you've got that one, if you've got A, you can try B. When 4 moles of O2 react completely, how many moles of H2O can be formed? Yes?
So this like 6 moles of H2. So what is like 2 moles of H2O?
So where did these 2's come from?
Yeah.
The 2's came from the coefficients in the balanced reaction. For every 2 moles of H2 that we react, we get 2 moles of H2O. You could simplify it to 1 if you wanted to, but usually we don't bother. Usually we just use the coefficients from the balanced equation. Coefficients from the balanced equation. Did that make sense? Yeah? Okay, cool. Whoops. Okay, so once again, we are finding the amount of product. So you see how we've done 2 calculations here. We found the amount of product from reactant number 1. We found the amount of product we can get from reactant number 2. So this is very much like the cheese and the bread. Yeah? And the water is the sandwiches. So if I were to ask you, what is the theoretical yield of H2O? What is the theoretical yield of water? How much water could we make? Could we make 6 moles? Could we make 8 moles? Could we make 7 moles? We can only make 6 moles, okay? So the theoretical yield of H2O is 6 moles because we choose the smallest number, right? If I can only make 6 sandwiches with this stuff and I can make 8 sandwiches with the other stuff, I can only make 6 sandwiches, okay? Or in this case, moles. We're on page 51 or somewhere near there. Maybe we're on 52, but it's really close to that. All right. So we know we can only make 6 moles. So who is our limiting reactant then? H2. So you go back here and you say, who is the reactant that gave me that? That was my H2 that gave me my smaller amount of product. Okay, so H2 gave us the smallest amount of product. I'm running out of room. Product. Okay. Which reactant is in excess? Well, that would be our O2. That gave us our bigger amount of product. That does not look like a 2. Let's fix that. And the reason I chose this particular example is because I wanted to show you something, because many times people will look at the original numbers. They'll say, I have more moles of H2 than I have of the O2, therefore O2 must be limiting. But that is absolutely 100% not necessarily true. You cannot look and say, whichever reactant has the smaller amount, that's my limiting reactant. That would be wrong, okay? You have to change it into how much product I could produce, because we're using up hydrogen at twice the rate we're using up oxygen. So it doesn't matter that we've got less oxygen, we're using up the hydrogen faster, so we run out of it sooner. Okay? So this question gets at that. O2 has 4 moles. That's fewer moles than H2, which has 6 moles. Is the reactant with the smaller number of moles the limiting reactant? No. Okay. How do you know which is limiting? Whichever one produces the smaller amount of product. Consider the following reaction. We have 3H2 plus 1N2 gives 2NH3. If we have 12 moles of H2 and 6 moles of N2, can we tell just from those numbers which is the limiting reactant? No. Okay, you got to dig deeper. You got to do some calculations. How many calculations do you need to do? 2 calculations. You will know when you need to do this because you'll be given an amount of this product and an amount of this reactant and the other reactant. If you have a regular stoichiometry problem, like the ones we were doing previously, you'll only be given a quantity of one of the reactants. Okay? So we need to find how much product can be produced by each reactant. That is 2 calculations. Do you guys think you could do those 2 calculations in the space provided in B? So you're going to do the 2 calculations down here. Yep. Yeah, it'll just be left over. It'll just be hanging about, doing nothing, because there's nobody left to react with. So if you don't know where to start for this question, there's like a little starting point there for you. Did you guys get the same numbers I got? Yeah? Okay, good. Which of those two numbers is our theoretical yield? The 8 moles. Okay, this is how much we can make. That is our theoretical yield. No.
Really?
Yeah. The only thing that's tricky about it is that people forget to do 2 calculations, or we're mixing like the regular stoichiometry with this stoichiometry, and people are trying to do limiting and excess when it's just a regular stoichiometry problem, or it's a limiting problem and they just do regular stoichiometry and forget about the, yeah. But really, there's not much more to it than this. The one little tricky part is we do ask you later how much of the leftover reactant is left. Okay, and that gets a little bit harder. Okay, not a lot harder, a little bit harder. So who is the limiting reactant? Hydrogen. Who is the excess reactant? Nitrogen. Excellent. Okay. And that's it for that. And now we're going to take a look at that next little tricky part, which isn't that tricky. How much excess reactant is left over? And we're back to our bread and cheese because that makes our life nice and easy. So our bread and our cheese makes one sandwich. And if we are given 3 slices of cheese and 4 slices of bread, earlier on, we decided that the bread was the limiting reactant. That's what we did earlier. And the cheese was in excess. How much cheese do we have to start with? We have 3 slices of cheese. How much cheese gets used up making these sandwiches? 2 slices. How did you know that it was 2 slices? Yeah, counted using what? What did you determine 2 slices from?
4 slices of bread.
You said with 4 slices of bread, I will use 2 slices of cheese. So you took your limiting reactant, the bread. How much cheese, which is our excess reactant, will react with all the bread? That's our limiting reactant. And this is always what you're going to be doing. You're going to be saying, if my limiting reactant reacts with the excess, how much of the excess gets used up? So you use your limiting reactant to figure out the amount of excess that gets used up. And then you say, okay, well, how much is left over at the end? Well, we know that we started with 3 and we used up 2, so it's going to be 1 slice. How did you figure it out? Cheese left over. Equals cheese minus cheese What could I fill in those blanks with that would make this make sense? I could put my initial, okay? Or I could say at the start, minus the cheese used up. All right, and that's how we find it, and that's how we're always going to do it. It's super easy. How did you figure out how much cheese? Oh, whoopsie. I got these backwards. I'm so sorry. How did we figure out how much cheese gets used up? Well, we said there were 4 slices of bread, which is our limiting reactant, times 1 slice of cheese for 2 slices of bread. Okay, I'm sure we didn't do it that formally. I'm sure we just did it in our heads, but that's what you're doing really. And that would be 2 slices of cheese. So you take your limiting reactant and you convert it into your excess reactant. And that gives you the amount of excess used up. You take your limiting and convert it to your excess. That gives you the excess used up. There are other ways of doing it. Sometimes people are like, I know how many sandwiches get made. And then they convert that into the amount of cheese that it took to make those sandwiches, and then they do the subtraction. Any way you can do it, as long as you're getting the correct answer, is totally fine. All right, so here we can see, yes, indeed, we have all this, we knew all that. So to find the excess reactant left over, that's leftover equals the excess at the start minus the excess used, and the excess reactant used. How do we find that? We convert the limiting reactant to excess, and that tells us how much gets used. So this is what I was talking about. You can figure out how much excess from the limiting reactant, or you can say how much excess reactant is used to produce that smaller amount of product. I'm not going to focus on that method, but if you want to do it, you can. Okay? Considering the following balanced reaction. Here we have 2 triangles and 3 squares. It should be pretty darn obvious that the square is the excess reactant, yes? So if we wanted to calculate how much squares were left over, I mean, we can obviously just see it, but how you would do that is you would take your limiting reactant and convert it to your excess reactant. So you would say, I have 2 triangles times 1 square per 1 triangle. Yeah, that's right. And you would get 2 of these little guys used up. And then you would say, okay, I started with 3. This is my start. This is how much is used. 3 minus 2 is 1. I hate this example. I need to come up with something better because this is just like too easy, I think. But anyway. 1. Okay. Before, after, there we go, 1 is left over. All right, let's do some actual problems with math. We are now on page 57. Earlier, we determined that when 6 moles of H2 reacts with 4 moles of O2, we found that H2 was the limiting reactant and O2 was the excess reactant. And that's when we had 6 moles of H2 and 4 moles of O2. That was on our previous worksheet. So what we're going to do, remember, is we're going to figure out how much O2 was used. So the amount of excess used up. So we're going to take our limiting reactant and convert it into our excess reactant. So our limiting reactant was the H2, and we had 6 moles of H2. And we want to convert it into our excess reactant. How much of the O2 is getting used up with that? So we want to find our moles of O2 and cancel moles of H2. We only use up 1 O2 for every 2 H2O. And so we get 3 moles of O2 used up. How many moles of O2 is left over? Take the moles of O2 at the start, subtract the moles of O2 used, and that's going to be the moles of O2 left over. So that's going to be, we started with 4 moles. We used up 3 moles. And so we have 1 mole of O2 left over. Do you want to try the next one on your own? Or do you want me to walk through it with you? Try it on your own? Very good. I'll just highlight some things up here. And when it says find the amount of N2 that is in excess, that means how much is left over. Okay, so that wording is in excess means how much is left over. So in order to solve this problem, I needed the moles of N2 at the start, which I was given. But I also needed the moles of N2 used, but I needed to calculate that. So I used my limiting reactant. Whoa, that was supposed to be like a highlight. There we go. I used my limiting reactant, converted it into my excess reactant, and that gave us how much of the N2 was used. That was our 4 moles of N2 was used to react with the 12 moles of H2, our limiting reactant. And then 6 was how much we started with, 4 was how much we used, so we have 2 moles of N2 in excess. Is good? Okay. So there are some questions here for you to do. And then you can try pages 60 and 61. So do pages 59, 60, 61, I think. 58 to 61.